All right, here we go again. Starting a new topic, and I hope that what we talk about in class, I capture here as well. Get the old badge. There we go. Let's have at it. Let's have a little fun and build our understanding, get some conversations started that we'll have for the rest of the semester. All right, so I just wrote out a little sentence here, a little written language. The value of the exponent that you put on top of a 5 to get the quantity 25 is a 2. And if we do our math that way, it's kind of cumbersome. It took me a long time to write that. And sure would be nice if we could perhaps change that into a symbolic language. So go ahead, have at it. Pause the video, tell me what I wrote. And if you're like most students, you probably are writing 5 squared equals 25. Okay. But that's not what I wrote. Okay, so let me get the eraser and let's go down a little bit. All right, and I'll tell you what I wrote. I changed the statement, the value of the exponent, into log. All right, so when you read the word log, it's short for logarithm. You want your brain to say, hey, I'm looking at an exponent. This calculation is all about the value of an exponent that I put on a base of 5. Well, we write the base here. That makes sense. Put it underneath a little bit. Gives you that feeling, strong base. Yeah. To get 25, well, this kind of fits the f of x notation now, right? We're performing an operation on a quantity. Or using a quantity, gets a 2, is. Okay, is, we can think of as an equal sign. An equal sign can also be thought of as may be written as. It's good to hear that at least once in your life, may be written as. That's what this equal sign means. In other words, 1 plus 2 may be written more simply as 3. Okay? And when we're doing algebra, we want to check things out. 2x plus 3x. Is it indeed 5x? Well, x stands for any number. So you plug a number in, and as long as it's true, it's true. So let's put 10 in. 2 times 10 plus 3 times 10 equals 5 times 10. Yes, 20 plus 30 equals 50. Okay. So when we use an equal sign, and we're working with simplifications, and you're a first or second year algebra student, you should probably occasionally put some numbers in to see if your statements are true and accurate. All right, so that's what this is about. So we have a new topic now. It's about logarithms, values of exponents. So therefore, I guess we better understand the operations, exponential operations. So let's begin a little look at that. Exponential operations. Well, I do believe, let me generate this rather than have it there already. 5 squared is 25. We know that to be true. And we just found what we call that exponential form. I think I have that written again down there, but repetition's our friend. And logarithmic form, log form, yes, I'll do log form like that, is the same information, but kind of written in an inverse process. Here we have an exponent getting a quantity, exponent of 2 getting quantity of 5. Here, the quantity of 25 gets us the exponent of 2. A to B, B to A, X to Y, Y to X. That's a little bit of an inverse form, logarithmic form, but we're more familiar with this. So let's go back to 5 squared equals 25. And then let's look at 5 squared. Let's get rid of the 2. Let's cancel it out. It comes back to 5. So this is squaring. Can you intuitively give me an answer here as to what that is? Well, if you said square rooting, you'd be right. Okay. 5 squared is 25. What undoes? Squaring, square rooting. Okay. So looks like the denominator, numbers in the denominator have something to do with roots. Yeah. So what's another way of saying Square root of 25. It may also be written as 25 to the 1/2, which is 5. Okay, we started the conversation. We keep having the conversation for a couple of minutes every day for the rest of your life. I think you'll learn that. I won't have it for the rest of your life, no. But the semester, yes. So can you pause the video and tell me what 8 to the 1/3 is? I just keep going, right? Well, a cube root of 8 may be written as 8 to the 1/3, which is 2. So what do we have? We have a base, and we have powers, and we have roots. Right? What undoes a third power? A third root. What undoes a fourth power? A fourth root. And a fourth root is something times something times something times something that gets us something. And the fourth root is one of those parentheses. All right, conversation has been started. Let's continue the conversation. Get a few more things in front of us that we can talk about repetitively. Repetitively, so you do it a lot, and something you do a lot, it's harder to forget. So what's another way of writing b times b times b? More simply written as b to the 3, b cubed. And you can think of it really coming from length times width times height. Algebra comes from geometry. Kind of builds off of geometry, geometric shapes. And then we extrapolate from there. All right, so what happens if I divide by b? Well, let's look at 5 times 5 times 5 divided by 5, which is 125 divided by 5, which is 25. Right? I think we can see a division there that we don't really have to spend a lot of time looking at. 5 into 5 goes once. And in this case, that 1, we really don't have to write because 1 times 25 is 25. So really, we started with 3 in the numerator. We have 1 in the denominator, and we ended up with 2. Okay. If this is an algebra 2 class, you already should know this. We subtract, yes? 3 minus 1. Really the difference of the number of factors in the numerator, the number of factors in the denominator. And what if we did b times b times b over b times b? Well, I think we can see the number 1 here times b, which means we really have 3 minus 2, which is b to the 1, which is b. And what happens if we have 3 of them? Whoa. We're not subtracting 2 anymore. We're subtracting 3, which gives us b to the 0. So b to the 0 is equal to this. Correct me if I'm wrong, but if we had 5 times 5 times 5 divided by 5 times 5 times 5, we have 125 divided by 125, which is the number 1, which is why something to the 0 is 1, because you have the same number of factors in the numerator as the denominator. You're dividing something by itself. Okay, key moment. Key moment. You're going to hear it often because this course is based on zeros and ones, and that's going to become a paintbrush. That's going to allow us to graph exponential functions in 10 seconds or less. It's coming your way with theater and review. Okay. All right, so let's just do a little practice. All right, day 1 of practice. Again, I think it takes about 4 days of seeing something to really get a handle on it for most folks. So you pause the video on each of these and I'll just do them. Maybe I'll do them slowly here. So I have 3 things here. I have 4. Oh, I should have done something else back here before I got to that. All right, what happens if we have 1 more here? 1 more. Well, it's not 0 anymore. B to the 3 minus 4. Ooh, I think we can still see the. I think we can still see that cancellation, right? 3 of them divide out. There's 1 here. How are we going to write that? How are we going to write 1 over b? Well, according to this, that's b to the minus 1. So b to the minus 1 really is about an extra factor. I guess I can call it a factor in the denominator. Want to guess what b to the minus 2 is? If you said 1 over b squared, you'd be right. So b to the 1 could be written as b divided by 1, and b to the minus 1 could be written as 1 over b. Kind of looks like the number 5. There you go, that's a b. I don't know why that's bothering me so much. B to the minus 1 could be written as 1 over b. So I think this minus sign did what to b over 1? Flipped it. So that's a reciprocation. So there are 3 parts to this. Let's bring it over here to make sure it's centered. There's 3 parts to this computation. There's reciprocation, which means if I did that first, I get 1 over 4. There's cubing, that's a power, right? Cubing. And 4 times 4 times 4, or 4 times itself 3 times, it's 64. And then there's square rooting. 4 to the 1/2 is 2. And it's not, I'm not cutting 4 1/2, I'm doing the square root of it. So that's a root, and that's a square root. Now, the interesting thing about these operations, doesn't matter which one you do first. We'll do them all 3 different ways. So we'll start here, 1/4, and then we're going to cube 1/4. Okay, we'll take 1/4 and we'll cube it. Well, that's 1 over 64. And then we'll take 1 over 64, and we will square root it. And if we square root 1 over 64, we get 1/8. Okay, let's try doing this a different way. Let's take 4 cubed. Let's cube it first, 64. Then let's take a square root. Let's take the square root of 64, which is losing the 2, which is 8. And then let's do 8 to the negative 1, which is reciprocating, flipping it, 1/8. Same answer. Why don't we start with square root of 64? Let's do the square root of 64, which is the same, square root of 4, which is the same thing as 4 to the 1/2. Let's repeat that again. That's 2. Okay, we did that. That 2 has been used, and we used that 2, and so now we have the number 2. Let's cube it. Well, that's 8. Okay, that's been used. Okay, and let's take 8 to the negative 1. Same answer. All right, so you get to decide the order in which you perform those operations. Now, just for quick practice, let's take this. This is exponential form, 2 to the 3 equals 8. How would you write it in logarithmic form? Pause the video, I just keep going. Logarithmic form is the base is 2. Okay, we're looking for the exponent we put on top of a 2 to get 1, to get an 8. And we know that that exponent is a 3. All right, so now we'll just do a few more practices, and then we'll load this up on the old channel, and then we'll give it to you as an assignment. All right, so you pause the video, give some thought to each of these computations that are in front of you, and I'm just going to do them out. Okay, so you pause the video, I start up. All right, so I know a new name for m squared times m to the 7th. Remember, I'm looking for the exponent on top of an m that gives me the exponent on top of an m in the parentheses. Well, I know m squared times m to the 7th, that's 9 of them. I know enough about this now to subtract, so that's 6. And if I do m to the 6 times 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 m to the 6, I think I did 6 times 5. That's 30. So what do you have to put on top? What number do you have to put on top of m to get the quantity m to the 30th? I think it's 30. Okay, let's keep going right around with my trusty science card. Boy, repetition's my friend. How many years I've done this without the science card? 125 to the 1/3. Pause the video. It's the same thing as the cube root of 125. That's what it's telling you. That's 5. That's that computation. Here's another one. Pause the video. I definitely want to do this operation first. I know that's the square root of 16, which is 4 to the minus 3, so I've done that. You know, and now that I've used it, I think I will do 4 to the 3, which is 64, with a minus sign. I think I'll put a 1 there. So I guess that's 1 over 64. You'll have one of each of those on every test the rest of the semester. And you'll have one of these every test. So what do you put on top of a 9 to get a 1/3? Well, I'm looking at roots and powers. What root helps me here? Oh, square root helps me. Square root helps me. Yeah, square root of 9 is 2. Square root of 9 is 3. I got the 3, but it's in the denominator. Gosh, it's in the denominator. I guess I got to do a little flip. All right, now that's conceptualizing. All right, and I'm sure if this is the first time you're hearing it, neurons need to connect, and that takes some practice. And it also takes showing the problem better with the screen. So let me go back and do that again. Let's talk about it. So I know I've got to have a minus sign here, right? Because this is 9 over 1. I got to get a flip. And maybe that's a better way of talking about it this time. And what root? I need a root to get to the number 3. What root takes me from a 9 to a 3 cube? Square root. All right. Now, as I said just a few seconds ago, this takes practice. So we're going to change this into exponential form. Okay, and I guess we're looking for that value, and that's an exponent. Maybe I'll even write exp. Where do exponents go? They go on top of bases. So I'm trying to find the exponent that gets this job done. Okay, and now I'm going to erase the p and the e. Okay. The thing about rules of exponents is you have to have the same base. So I think 9 can be written as 3 squared. And I think, if I'm not mistaken, you multiply here. So that's 3 to the 2x. And I think we've done this enough now that we can probably say another way of writing 1/3 is 3 to the negative 1. That should be able to follow. Oh, glad I said the word follow. Learning. The first step in learning is following what I'm saying. The second step is doing it yourself. And you'll get a chance to do that with the worksheets in class. And the third stage of learning is explaining it to somebody. And I heard that from my good friend Sam Richardson years and years ago, and I couldn't agree with him more. So, thank you, Sam. That's had a profound influence on my teaching career, hearing you say that. I think I tell everybody in my class that quite often. Your job is to get here, all right? And being able to explain it to a 9-year-old. Okay. Next, where were we? Oh, I think we can see that 2x has to equal -1. So our exponent was -1/2. All right, so that's been finished. I'll work up from here. So we're looking for an exponent. You pause the video. Okay, maybe you already know what powers and roots convert this to that, but let's do it algebraically as well. 125 to the x equals 25. 25 is 5 squared. 125 to the x is 5 to the 3x. Rules of exponents say 5 to the 3x equals 5 to the 2. Therefore, 3x equals 2. And our answer is x equals 2/3. Do you remember what that 3 means? Cube root. What's the cube root of 125? What times what times what gets us 125? I hope you say the answer 5. So if I take the cube root of 125, I get 5. What do I have to do exponentially to turn a 5 into a 25? Square it. All right. So graphing this, I'm not going to spend any time because I really need to give you more practice with this before I really do this, but I'm a big fan of planting seeds. That's what that graph's going to look like. And let's see if I can just give you some data points. I think the easiest one might be a 2. Okay, so if this is x equals 2, what do you put on top of a 2 to get a 2? Hope you'd put a 1. What do you put on top of a 2 to get a 4? And the number 4 is, remember your x-axis is horizontal, right? So right now I've identified a 2. Can you see that? Not really. Okay, so I'm 2 horizontal. Now I got to go to 4 horizontally, which is, the 0's over here. So I'm kind of stuck with the 0 over here. I already wrote it. So here's a 0. And so that's a 2. Ooh, I don't know if I like this. And that's a 2. And if that's 2 units, then I got to go to 4. And then I got to go to 8, which is 4 units. I didn't anticipate this, but 8 units. Let's just stop there. I don't think we're going to see anything too much more than that. All right. So a 4, I'm going to have to extend this. Okay, so a 4 gets me 3 units, right? Because 2 to the 3 is, 2 units. Okay, if I put a 4 in here, I have to square a 2 to get 4. I'm already thinking about 8, which is way out here, right? And so if I have 8 units, log base 2 of 8 equals 3. So I hope you can see that it's taking a bigger and bigger quantity to go up 1 notch exponentially. And in the other direction, so if this is 2, then this is 1. Right? That's 1. And what do you have? What exponent you put on top of any base? 2 to the what equals 1? Well, we talked about that before, and I'm a big fan of repetition, so that's a 0. Sure looks like we're going from 3 to 2 to 1 to 0 to -1. So this probably is there. Jump a 1, jump a 1, jump a 1, jump a 1. That looks better now. And so I think 1/2 gets me -1. Maybe you're starting to get a little feel for this. Right? It's asymptotic behavior. 1/4, -2. In other words, 2 to the -2 gets me the quantity 1/4. The log base 2 of 1/4 gets me an exponent of -2. Okay. Now, one of the reasons we're starting this now is students notoriously have trouble with logarithms. And in a typical class, you might be lucky if you get a week of study. Well, you're going to get a longer than a week of study on logarithms. You're going to get from now until the end of the semester. All right, but 5 minutes, 10 minutes a day. But every day until you get a chance to reflect, to look at it critically, to make the connections. And last thing I'm going to say is, this process, there's 2 types of processes, doing something sequentially and doing something holistically. All right, a sequential, I'll give you an example of a typical sequential. You see something for a week, you work with it, then you move on. And think of your vocabulary tests. I know if you're anything like mine, we used to get 30 words. Okay, you get them on Monday, you test it on Friday, breeze through it, memorized them. A month later, if you asked me what the words were, probably couldn't tell you. If you're not working with them, constantly, you're going to forget. It's just the way things are in life. Okay. So what if we were to do, instead of, half an hour a day, memorizing 30 words, what if you did 2 minutes, 15 days? Something like that, or just, 1 word every day. One look, just 1 look, read the page. This means this means that, so on and so forth. Put it away, come back. This means this means that, this means this, put it away. That's what we're going to be doing in this class. Okay, and you're graded at midterm and you're graded at the end of the term. And we'll be looking for your best effort. Show us how many things you can put in your pocket. All right, I'm starting to rant again. Better shut up. Here we go.